OSPF version 3 LSAs. In this video, I am going to talk about the LSAs in the OSPF version 3. And also, I will compare the LSAs of the OSPF version 3 with the LSAs of the OSPF version 2. But let me to say that some of the concept of this video is a little beyond the scope of this course, but all of them are informative for you for understanding the differences between the OSPF version 3 and OSPF version 2 LSAs, and also you will learn about some of the benefits of the OSPF version 3 in compared with the OSPF version 2. In this table, we can see the LSAs that we have in the OSPF version 3, okay? In some of the LSAs, we are experiencing only a change in the name of LSA. And also, in some other LSAs, we have some differences inside of the content of the LSA. For example, let me to review them. I will talk about them in this video. Look at here. In OSPF version 3, the LSA type 1, okay, is the code of LSA is, for example, 0x2001, but you can say LSA type 1, okay? This is the LSA function code. LSA type 1 or LSA type code 0x2001. In most cases, we say LSA type 1. LSA type 1 has the name of router LSA, exactly same as the, for example, LSA type 1 in the OSPF version 2. Let me to write here, this is informative. In OSPF version 2, okay, about the LSA type 1, we are using the same name, router LSA, but I will talk about the detail of the LSA type 1 or router LSA. Let me to say that here we have some differences between the LSA type 1 and also LSA type 1 of OSPF version 3 and LSA type 1 of OSPF version 2. I will talk about those differences in this video. After that, we have LSA type 2, and the name of this LSA type 2 is network LSA, okay? I will talk about the LSA type code, don't worry about them. For now, let me to talk about the LSAs itself. The LSA type 2's name is network LSA, exactly same with the OSPF version 2, okay? But also here we have some differences in the content. I will talk about them. About the LSA type 3, as you can see in the OSPF version 3, the name of this LSA is Inter-Area-Prefix LSA. But in the LSA type 2, in the OSPF version 2, we are using the name summary LSA or network summary LSA. Because of that, here we have a change in the name. But about the contents of these two LSA are same. Actually, only the name is changing. You will learn about the reason that why we are using Inter-Area-Prefix. The reason is that now here we have another type of LSA, new type of LSA, LSA type 9. The name of that type of LSA is Intra-Area-Prefix. Because of that, LSA type 3 changed its name to the Inter-Area. Inter-Area in compared with the LSA type 9 names Intra-Area. Okay, here we have one change in the difference between the names, but about the content are same. After that, you know that LSA type 4's name is ASBR summary in OSPF version 2, but in the OSPF version 3, the LSA type 4's name is Inter-Area Router LSA. Here also about the content, we don't have, for example, differences, but about the name we have difference. Okay, ASBR summary changed to the Inter-Area Router LSA. After that, about the LSA type 5, you know that in the OSPF version 2, we are using AS external or external. Here also, we are using the AS external or external. About the LSA type 6 in the OSPF version 2, the name of this type of LSA is the group membership LSA. Also in the LSA, in the OSPF version 3, the name is same. And in both versions, the Cisco doesn't support them. Actually, we can say in the OSPF version 3 and OSPF version 2, we cannot use the LSA type 6 in Cisco, for example, implementation. After that, about the LSA type 7, The name of type 7 LSA is type 7 LSA. In the OSPF version 2, we say NSSA external. About the content, we don't have many differences between them, NSSA external. But now here we have two new type of LSA. In the OSPF version 2, the name of LSA type 8 is opaque LSA, and also the name of LSA type 9 is opaque LSA. But here, as you can see, the name of the LSA type 8 is link LSA. You will learn about them in this video. And the name of LSA type 9 is Intra-Area-Prefix LSA. Also, we have LSA type 10 and type 11. Both of them are opaque. But as you can see, in the LSA type 9, type 1 to LSA type 9 of OSPF version 3, we have some differences. About the content, okay, we have differences between the LSA type 1 of the OSPF version 2 and OSPF version 3 and LSA type 2. Also, we have two new type of LSA, 8 and 9, okay? But about the change in the name, in type 3 and type 4, okay, we have a change in the name. I will talk about first the modification, the change between the LSA type 1 of the OSPF version 3 and OSPF version 2 in this scenario. After that, we will talk about other differences. As I mentioned before, here we are experiencing some topics a little beyond the scope of this course, but this is so informative. Let me to start with this scenario. Here we have a simple scenario, include three routers, R1, R2, and R3. All of them are residing on area quad 0. As you can see, we have both IPv4 and IPv6 in this scenario. I want to configure this scenario with two versions of the OSPF. OSPF version 2 for IPv4, okay, and OSPF version 3 for IPv6. Why? Because I am going to show you the differences between the different LSA types. Okay, this is so informative. Here we have one notepad file. We can start the configuration of this scenario from the router 1 en-conf-t. First, on each interface, we should configure two IP address, IPv4 address, IPv6 address. On the router 1, interface serial 10, IP address 10.121.255.255.255.0, and then no shutdown. Okay, this is the IPv4 address. Also, let me to configure IPv6 address. IPv6 address 2001 db8 12:1/64. Also, for easier verification, let me to configure the link local address. IPv6 address FE80:1 link local. That's it. This is the configuration of the IP addressing on the interface serial 10. Let me to copy it for the interface serial 11. Okay, the IP address of this interface is 10.131. Okay, /24.255.255.255.0. IPv6 address is 2001 db8 13, okay, :1/64. IPv6 address FE80:1 link local is same and no shutdown. That's it. Also, we have another interface loopback 0. Let me to configure this loopback 0. IP address is, for example, quad 1, then quad 255. Okay, and after that, IPv6 address is 2001 :1/128. After that, here we don't need to configure the link local address, and after that we don't need to enable it. The loopback always is on by default. Okay, this is the configuration of the R1 without OSPF. Now let me to configure OSPF router OSPF, for example 1. After that, here we should configure, for example, router ID to quad 1. Okay, after that, let me to use this command network 10.121 the quad 0, then area quad 0. All of interfaces are residing on the area 0. Network 10.131 quad 0, then area quad 0, and after that network, okay, network, then quad 1 quad 0, okay, area again quad 0. Now let me to configure OSPF version 3 router OSPFv3 1. You know that first we should enable IPv6 unicast routing, IPv6 unicast routing. After that, router OSPFv3 1, and then router ID, for example, quad 1. And after that, we should configure the interfaces with this configuration. Let me to configure interface serial 10 OSPFv3 1 IPv6 area quad 0. That's it. Also, we have two other interfaces. Let me to copy this command. Interface serial 11 and also interface loopback 0. As you can see, the configuration is so easy. Okay, this is the configuration of the router 1. Let me to copy this configuration on the router 1. Okay, this is the configuration of the router 1 here. Okay, as you can see, we don't have any error message. Because of that, we can copy this configuration for the router 2 also here. This is the router 2 configuration. We should change some things here on the router 2. Starting from the serial 10, the IP address is 10.122.255.255.250. IPv6 address 2001 db812:2/64, and IPv6 address FE80:2 link local. That's it, no shutdown. Interface serial 11. Okay, here we don't have any interface serial 11. Let me to remove it. We have interface loopback 0, IP address is quad 255 and 2001:2/128 is the IPv6 address. Then router OSPF1, router ID is quad 2. Then network statement include network 10.122 quad 0 area 0. We don't have network statement here. Again, network quad 2 quad 0 area quad 0. That's it. IPv6 unicast routing, router OSPF version 3.1, router ID is quad 2. Then over the interface serial 10, we need to configure OSPF version 3.1 IPv6 area quad 0. We don't have an interface serial 11. Then interface loopback 0, OSPF version 3.1 IPv6 area quad 0. Let me to copy this configuration to the CLI of the router 2. Okay, this is the CLI of router 2. Okay, as you can see, we don't have any error message. Also, finally, let me to use it for the configuration of the router 3. After that, we can start talking about the link state advertisement. Here, router 3, interface serial 10, the IP address is 10.233, okay, 10.233, and then 10.133, okay. After that, 255.255.255.0, IPv6 address 2001 db813:3, and then IPv6 address FE80:3 link local. And after that, interface loopback 0, IP address is quad 3, okay, quad 3 quad 255, IPv6 address 2001:3/128, okay. And after that, here on the for example router OSPF1, we should configure router ID quad 3, then network 10, okay, 10.133 quad 0 area 0, and after that network quad 3 quad 0 IPv6 unicast routing, router OSPF version 3.1, router ID is the quad 3, okay. And after that, interface serial 10 OSPF version 3.1 IPv6 area quad 0, and interface loopback 0 OSPF version 3.1 IPv6 area 0. It is okay. Let me to copy the configuration of the router 3, and then we can paste it on the R3 CLI. Now our configuration is completed. First, we should verify the OSPF operation. After that, we can talk about the link state database starting from the router 1. Okay, in the router 1, we can use two commands for verifying the neighborship. Show IP OSPF neighbor for the IPv4. We have two neighbors with the router 2 and router 3. And also show OSPF version 3 IPv6 neighbors can show us we have two neighbors. And here you can see the differences between the result of IPv4 and IPv6 neighborship. Look at here, everything is same. Instead, only we have in the interface ID some differences. You will learn about it in this video. Interface ID 5, but here you can see the IP address of the other side. This is the only difference that we have, and we will learn about it. Also, let me to show you the routing table of R1. Show IP route OSPF. In R1, we have learned quad 2 and quad 2/32 and quad 3/32 from the router 2 and router 3. It is okay. And also in this router, let me to show you, show IPv6 route OSPF. Here also we have learned 2001:2/128 and 2001:3/128 from the OSPF version 3. As you can see, the result is same about the administrative distance, about the for example metric. Here we have difference in the metric. The metric of the loopback 0, okay, in the router 2 is 0. Because of that, here we can see only 64 as the metric, but in the OSPF version 2 the metric of loopback is 1, and because of that we can see the 65. It is not so important, but we should know about them. Here also about the next hop, we are using the IPv4 address of the next hop interface, but here we can see the link local address of the next hop interface as the in the routing table. Now I'm going to talk about the database. You know that actually we want to learn about the database. In the database of router 1, you expect to have 3 LSA type 1 only, okay, because this is single area, we don't have LSA type 3, and because here we don't have any transit network or any broadcast network, we don't have LSA type 2, and because we don't have any redistribution process in this scenario, we don't have LSA type 5, type 4, and also type 7. Here we expect to see only 3 LSA type 1. Let me to show you. Show IP OSPF database can show us we have only 3 LSA type 1. Let me to copy it. It is maybe useful for us in the notepad file. This is the LSA type 1 of the router 1. You know that the database exactly same between the router 1 and also router 2 and router 3. Why? Because all of them are residing in one area, for example 0. Okay, now let me to show you the database of the OSPF version 3. It is so easy. You have learned about the command for verification of the database of OSPF version 3. Show OSPFv3, okay, after that IPv6, then database. Okay, here we have more information. We should talk about them. Let me to copy this information. Okay, we will learn about them. It is so easy. Look at here, copy and then paste it here. Okay, this is the database of R1 from here for the IPv6 or OSPF version 3. Here we have more information. Let me to review them first. As you can see in the database of router 1, again we have 3 router link state. Means we have 3 router link state in OSPF version 2. This is OSPF version 2. Look at here, OSPFv2. Okay, and here we are using we can see the database of OSPFv3. As you can see about the OSPF version 2 and OSPF version 3, about the numbers of the LSA type 1, we don't have any difference. Okay, 3 LSA type 1, 3 LSA type 1. Actually, in the OSPF version 3, each router should create 1 LSA type 1. It is same. But as you can see here, now we have LSA type 8, okay, and LSA type 9, the new type of LSAs that we know about them. Actually, we don't have any difference between the LSA type 2 and type 3 and type 4 and type 5 and type 7. Okay, here only we are experiencing the new LSAs, LSA type 8 and LSA type 9. The first type of LSA that I want to talk about, that is the LSA type 9. Okay, the LSA type 9 name is Intra-Area-Prefix LSA, and this is the new LSA type that we have in the OSPF version 3. Before talking about the LSA type 9, let me to say that OSPF version 2 LSA type 1 content equal to the OSPF version 3 LSA type 1 and type 9. Actually, we can say the informations that are available in the OSPF version 2 LSA type 1 now are residing on 2 LSA, LSA type 1 and LSA type 9. You will learn about the reason of this segmentation. But now you know that all of the information that you have learned previously in the LSA type 1 of OSPF version 2, okay, now are residing, are available in 2 LSA types, LSA type 1 and LSA type 9. Maybe you want to know why we are dividing the information of the LSA type 1 of OSPF version 2 into 2 type of LSA, LSA type 1 and LSA type 9. I will talk about the reason of this, but let me to say that because of the more efficiency. Let me to explain about the more efficiency of OSPF version 3 LSA type 1 and type 9 in compared with the one type of LSA type 1 of the OSPF version 2. Look at here, assume that we are talking about the OSPF version 2, okay? You know about the OSPF version 2 and its functionality. For example, if you change the IP address of loopback 0, okay, from the quad 1 to the 1112, okay, assume that we are changing the IP address of quad 1/32 to 1112/32. You know that the R1 should create a new LSA type 1, okay, and send to R2 and R3. Because of that, both of them should calculate again the SPF. Let me to show you. Here, this is the configuration of the router 1, okay. First, let me to add one router statement, router OSPF1. Okay, or yes, router OSPF1. Here we can configure network 1112, okay, quad 0, area quad 0. This command now doesn't have any effect. Why? Because we didn't configure 1112, okay. Before adding the 1112, before changing the IP address of the loopback 0 to 1112, let me to show you in the router 2 until now, okay, show IP OSPF can show us that we have executed the SPF algorithm 4 times, and in the router 3 show IP OSPF it can show us we have executed the for example SPF 2 times. Also in the database we have the numbers of the sequence number. Show IP OSPF database. We show IP OSPF database in the router 3 can show us that the sequence number of the quad 1 LSA is 5. Okay, now let me to change this. For example, IP address interface loopback 0. IP address is 1112. Okay, 255.255.255.255. What is happening? First, in the router 3, we expect to see one increase in this sequence number. Look at here. As you can see, this sequence number increased to 6. After that, in the router 2, you will see that the SPF algorithm should execute it. Look at here. Show IP OSPF. As you can see now, SPF algorithm changed to the 5 from the 4. Look at here. Before it was 4. Now it is 5. Okay, this means that for each change in IP address, okay, and also in the topology, for example, we are adding one link, we should send one new LSA to the other routers. Okay, this is normal, but it is not so efficient. Now we have this IP address. Why? You know that with changing the IP address of the loopback 0, actually the topology doesn't change. Okay, the topology is same. Only you can, in the router 2 and router 3, change the IP address of quad 1 to the 1112. That's it. For example, previously we had 1112, okay, 1111 means quad 1. Now we can replace the quad 1 with the 1112. That's it. We don't need to execute the SPF again. Okay, this is not so efficient. Assume that you are working in large network, and for each change in IP address, we should calculate again the SPF. Okay, about the IP address changing, okay, about the addressing, we don't need to calculate the SPF. Only we can replace the IP address with another IP address. That's it. Okay, but if we experienced a change in the topology, yes, we should use the SPF algorithm. For example, I assume that the R1 link to the router 2 change from this link failed. Okay, when the serial 10 is not available, yes, the R3 should calculate again the SPF, for example, for another pass to the router 2. It is okay. But about the change in the address, we don't need to, for example, change and calculate the SPF. This is the problem of OSPF version 2. In OSPF version 3, in LSA type 1, we don't have any information about the addressing. Only we have information about the connectivity to the other routers. Let me to review OSPF version 1 of the OSPF version 2, OSPF LSA type 1 of OSPF version 2. Look at here. In OSPF version 2, in LSA type 1, we had this information. I have connected to, for example, which network, okay, and which, for example, with which mask, with which cast, okay. Also, for example, I am connected to with this interface IP, okay, interface IP to which neighbor, okay, RID. You have learned about it, okay? For example, in the OSPF version 2, LSA type 1 of the router 1, we had this information, LSA type 1. I am connected to the quad, for example, 1112, okay, or quad 1/32, okay, with the cost of 1. Also, to the 10120/24 with the cost of 64. Also to the 10130, okay, /64 with the cost of /24, okay, with the cost of 64, okay. And also, for example, I have connected to the router 2 with the 10121 to the router 2 RID of quad 2, okay, and then with the 10131 I have connected to the RID of quad 3. You have learned about the content of the LSA type 1 previously, okay. This means that we have two types of information. First, the addressing information. Second, the topology information, okay. In the LSA type 1 of the OSPF version 3, okay, let me to show you. I will show you the detail. Here only we are reviewing the general concept, okay? As you can see, in the LSA type 1 of the OSPF version 3, we don't have information about the network that this router connected to them, okay? We don't have this information. This information, okay, are going to the LSA type 9. I will talk about the detail of LSA type 9, but here we have this information, LSA type 9. Okay, let me to write the generic information in the LSA type 9. Intra-Area-Prefix means the inside of area prefixes, okay, it is new. Or for example, in the router 1, I have connected to quad 1/32, for example, with the cost of 0 or 1, okay, this is not important. After that, 10120/24 with the cost of 64, okay, and then 10130/24 with the cost of 64, okay. Here we have this information, intra-area-prefix. But in the LSA type 1, we have only the topological information, okay. Topological information means I have connected to which router, okay. For example, to a neighbor quad 2 and quad 3. Here we have this information. I have connected to quad 2 and quad 3. Also, we have another change. You know that we don't want to use the IP address. Why? Assume that we are changing the IP address of one interface. If you use the IP address in the LSA type 1, you should send again another LSA type 1. Look at here, in the OSPF version 3, each interface has a unique interface ID. This is select randomly in router. For example, this interface has 5 interface ID, this 6, okay. What does it mean? Here in the information of LSA type 1, you can see that with the interface ID of the, for example, 5, I am connected to quad 2. And also with the interface ID of the, for example, 6, I have connected to the quad 3. That's it. We don't have any addressing information. What is the usage of this LSA type 1 and type 9? Look at here. Assume that now again the quad 1112, okay, or for example the IPv6, for example this, because we are talking about OSPF version 3, this IPv6 address change to 2001:2/100 or $5/128, okay. You know that now the LSA type, for example, 1 doesn't change. You know that here I have used the IPv4 because OSPF version 3 can support the IPv4 and IPv6 also. But if you want, you can replace them with the information of the IPv6. I will show you. When you are experiencing a change in the, for example, only addressing, we should advertise LSA type 9. And with the LSA type 9 advertisement, the routers doesn't calculate the SPF. Only they are replacing the addressing. That's it. But if you experience some change in the, for example, topology information, you should advertise the LSA type 1 and other routers, okay, should calculate the SPF again. Actually, we have two types of information in OSPF version 3 LSAs. Type 1 include topological information, type 9 include addressing information. When we are experiencing a change in the addressing, we should send type 9, only type 9. When other routers receiving type 9 information, type 9 LSA, all of them should replace the addressing that we have on the type 9 LSA and without the SPF calculation. But if they are receiving LSA type 1 from, for example, router 1 because of one change in the topological information, they should calculate the SPF. This means that this is more efficient than the OSPF version 2 that for all type of change, for example, changing in one IP address, we should calculate the SPF. This is not so efficient. Let me to say that previous than the OSPF version 3, in the ISIS intermediate system to intermediate system, we have used this method. Actually, we can say ISIS is more efficient compared with the OSPF version 2. You know that ISIS is another link state protocol, okay? And OSPF version 3 now also is using the method that we have used before in the ISIS. Because of that, now we know about the functionality of the LSA type 1 and type 9 and the benefits of them in the OSPF version 3. But let me to show you now the detail of the information that we have in the LSA type 1 and type 9. After that, we can talk about the LSA type 8. Let me to show you the content of the LSA type 1, type 9 of the OSPF version 3. Okay, here in the router 1, we can use show OSPFv3, okay, IPv6 database for verification of all of the LSAs that now we have here. First, let me to show you the LSA type 1. Here you can use show OSPFv3, okay, IPv6 database, then router. Again, like the OSPF version 2, we should use the LSA name. After that, we have multiple options. For example, you can use advertise router, and after that, the router ID of the router that you want to see the LSA of that router. Also, if you want, you can use self-originate, means the link state of this router 1. Let me to use advertiser router. This is easy, ADV router, and then quad 1. Okay, means please show me the LSA type 1 of the router 1. Okay, here you can see this information. Okay, I will talk about many things here, but for now, let me to show you the, for example, the content. Let me to talk about the main content. Look at here in the router 1. It is so easy. We have only topological information. Before talking about the topological information, if you want, you can use show OSPF, okay, v3 IPv6 interface, okay, brief, to see the interfaces that you have in the OSPF, okay. Also, show OSPFv3 IPv6 interface, for example, serial 10, okay. It can show us the interface ID of this interface to us. For example, serial 10 is using the interface ID of 5, and then serial 11 is using the interface ID of 6. Okay, look at here about the show OSPF IPv6 loopback 0, IPv6 interface loopback 0. Okay, here we have this information. Okay, process ID, instance ID, because the loopback 0 doesn't connect to any, for example, a router. Here we have a little less information, okay, lower information, but here you can see interface ID of 10. This is not so useful, but now we know that interface loopback 0 has in this router, okay, has the interface ID of 10. Okay, after that, in the router 2, show OSPFv3 interface serial 10 has the interface ID of 5, okay, in this router, and loopback 0 show OSPFv3 interface loopback 0 has the interface ID of 10. In the router 3 also show OSPFv3 about the IPv6 about the interface serial 10 has the interface ID of 5. This is only random, okay. We don't have any rule about the interface ID number. Okay, here we have interface ID of 5 and also 5. Now we can better understand the content of the database. Starting from router 1, show OSPFv3, okay, IPv6, for example, interface, IPv6 database, okay, router, advertised router, quad 1, that's it. Look at here, we have this information. First, you know that the advertising router is quad 1, okay. About the, for example, LS type, we know that this is the router link state, as I mentioned before. After that, a number of links to means we have 2 link, okay, in the router 1. First, link connected to another router. This is the point link, okay. Link metric is 64, okay. As you can see here, we are using serial 10 and the link metric is 64. Local interface is 6, this link, okay, is 6, and the neighbor interface ID is 5. It is okay because we have neighborship with the router 3, and neighbor RID is a quad 3. Actually, in the LSA type 1 of router 1, we have this information. Let me to write here, this is informative. R1, okay, LSA type 1 with this interface ID, in local interface ID, let me to write here, local interface ID of the 5, okay. I am connected to the neighbor, okay, interface ID of the here with the router 25, and also to the router ID of quad 5, and also with the cost of 64. That's it. Okay, this is the information that we have in the LSA type 1 of the router 1, okay. And also let me to copy it again for router 3. We have similar information. Local interface ID is 6, okay. Here local interface ID is 6. Neighbor interface ID is for example 5, okay. And also the neighbor remote ID router ID is quad 3. Here we should use the neighbor RID quad 2, okay. And then cost is 64. That's it. Here you can see this information. So easy. First, local interface ID, neighbor interface ID, neighbor router ID, and then link metric. That's it, okay. Link metric or cost. Also, in the information of the router 2, we expect to see this information: LSA type 1, local interface ID 5, connected to neighbor interface ID of 5, RID of neighbor is quad 1, okay. And then the metric or cost or link metric is a 6. This is the information that we have in the router 2, okay. After that, let me to copy it for router 3. This is the R2 and this is R3, okay. In R3 we have this information: LSA type 1, local interface ID 5, I am connected to the neighbor interface ID of 6, okay. After that, the RID of neighbor is quad 1 and the cost is 64. As you can see here, we don't have any IP address. Because of that, only when we are experiencing a change in the topology, means in the link, we should advertise one LSA type 1 and other routers should calculate the SPF, okay. But let me to show you the content of the LSA type 9, okay. Before talking about the LSA type 9, show OSPF v3 IPv6 neighbor. It can show us we have 2 neighbor, router 2 and router 3. Both of them are using the interface ID of 5. Now you can understand this interface ID as I mentioned before. Also in the router 2, let me to show you. Show OSPF, okay, v3 IPv6 neighbor. It can show us that this quad 1 has the interface ID of 5, and also in the router 3, show OSPFv3 IPv6 neighbor. It can show us our neighbor has the interface ID of 6. It is okay. Now it's time of talking about the LSA type 9, the new type of LSA. Show OSPFv3, okay, then IPv6, then database. Here we have some options, okay. The option for the LSA type, for example, 1 is the router LSA. The option for LSA type 2 is the network LSA. The option for LSA type 3 is the inter-area LSA, okay. And also we have another options for other routers, but we are talking about the LSA type 9. For LSA type 9, we can use prefix link state. Show OSPFv3 IPv6 database prefix. Again, advertised from the, for example, router 1, quad 1. It is so easy, okay. Here we have this information and all of them are so understandable. Look at here again. Advertising router, quad 1. LS type, Intra-Area-Prefix LSA, as I mentioned before. Intra-Area-Prefix LSA. After that, here we have this information. Look at here. First, I have connected to 2001 double column 1, okay, slash 128 with the metric of 0. Metric of loopback is 0. Then 2001 db813 means this link with the metric of 64. That's it. 2001 db813 double column slash 64, okay, and then 2001 db8 column 1 double column 2 slash 64, okay, with the metric of 64. Let me to write them here. On the R1 LSA type 9, okay, we have this information. It is so easy. And here, for example, 2001, okay, double column 1 slash 128, metric is 0. Then 2001 db8 12 double column slash 64, metric is 64, and also 2001 db8 13, okay, double column slash 64, the metric is 64 again. This is the information that we have in the LSA type 9 of the router 1. Let me to copy it for the router 2 and also the router 3, okay. This is for router 2, this is for router 3. Router 2, 2001 double column 2 slash 128, metric is 0. 2001 db8 12 double column slash 64, metric 64. That's it. Okay. And then in the LSA type 1 of the type 9 of the router 3, we have this information. 2001 double column 3 slash 128, metric is 0. 2001 db8 13 double column slash 64, metric is 64, and that's it. Okay, I will show you. Here in the LSA type 1, here we can use show OSPFv3 IPv6 database prefix advertise router quad 3. As you can see, we have only these two line. Advertising router is quad 3, and then 2001 db8 13 double column slash 64 means prefix address prefix length. The metric is 64. Also, here you can see about the, for example, 2001 double column 3 slash 128, the metric is 0. Also show OSPFv3 IPv6 database prefix advertise router quad 2. We have similar information. 2001 db8 12 double column slash 64, metric is 64. And also, as you can see here, now we have 2001 double column 2 slash 128, metric is 0. It is so understandable. Now let me to show you when one, for example, address is changing in the OSPFv3, we don't need to calculate the SPF. Look at here in the router 1. Show in the router 2 first, show OSPFv3 IPv6, okay, can show us that until now we have executed 5 times the SPF, okay, in the router 2. And in the router 3, show OSPFv3 IPv6, okay, can show us that we have executed the SPF algorithm 3 times until now. And also in the router 3, show OSPFv3 IPv6 database can show us the sequence number of LSA type 1 of the router 1 is 4, okay, and LSA type 9 of router 1 is 6, okay. Let me to show you what is happening when we are changing the IP address in one interface. For example, loopback IPv6 address, interface loopback 0, no IPv6 address, okay, this is one change, no IPv6 address. Okay, because you know that if we configure IPv6 address, this IP doesn't replace the previous address. We should use no IPv6 address. Okay, and then IPv6 address 2001 db8 2001 double colon 10 slash 60 slash 128. Okay, that's it. Now let me to show you what is happened in the router 2. In the router 2 or in the router 3 first, let me to show you, we are using show OSPFv3 IPv6 neighbors. As you can see, about the LSA type 1, we don't have any difference. But about the LSA type 9, we have one change in the one increment, okay, in the, for example, LSA type 9. The reason is that the router 1, it should send only one LSA type 1, okay, one LSA type 9, not LSA type 1. About the SPF calculation, as you can see here, now we don't have any new SPF calculation. Why? Because the R1 sent only one LSA type 9 and we don't need to calculate the SPF again for when we are receiving LSA type 9. This is so, for example, important about the efficiency. Now we know about the LSA type 1, LSA type 9, okay, and the differences between the OSPF version 2 and OSPF version 3. As you can see, the OSPF version 3 is has more efficiency in compared with the OSPF version 2. Look at here, Intra-Area-Prefix LSA means the prefix for intra-area, for inside of the area. Because of that, because we are receiving the LSAs from other areas with the summary LSA, the Inter-Area-Prefix LSA is better name in contrast with the intra-area. Because here we have LSA type 9 with Intra-Area-Prefix name, we can use Inter-Area for the summary. Because of that, as you can see, the name of LSA type 3 changed to the Inter-Area-Prefix. That's it. Also, we have some differences in the network LSA. For understanding the differences in the network LSA and also in the OSPF version 2 and OSPF version 3, let me to add one link here between the router 2 and router 3. Okay, this is the new link. Okay, new fast Ethernet 00 that we have here. Also about the IP addressing, I'm going to use this range. Look at here, 10.2.30/24. And after that, for IPv4, 2001, okay, DB8, 2.3, okay, 2.3, :/64 for the IPv6. Let me to configure them. It is so informative. In the router 2, okay, we should configure the interface fast Ethernet 00. IP address is 10.2.3.2.255.255.255.0. IPv6 address is 2001 DB8, for example, 2.3, okay, :2/64, okay. I will enable this interface, but for now, let me to wait some second. After that, in the router 3, interface fast Ethernet 00, IP address is the for example 10.2.3.2.255.255.255.0, and then IPv6 address is 2001 DB8 2.3 :3/64. I will enable it. Before enabling this link, let me to explain first the LSA type 8, okay, because it is so easy. After that, we can talk about the LSA type 2. Look at here, you know that about the LSA type 8, the functionality of the LSA type 8 as link LSA is advertising the link local addresses. You know that in IPv4, we don't have a link local address. In IPv6, we have link local address. Because of that, in OSPF version 2, we don't have a counterpart for the, for example, advertising of link LSA, but in OSPF version 3, we have. For example, it is so easy. Let me to show you. In the router 1, now you know that we don't have this link because I didn't enable the fast Ethernet 00. Let me to remove it for some second. In the router 1, you can verify the show OSPFv3 IPv6 database. Look at here. Here we have this database include 4 LSA type 8. Why we have 4 LSA type 8? Let me talk about that. You know that router 1 connected to 2 link, okay, serial 10 and serial 11, okay. For each of them, the router 1 should advertise 1 LSA type 8, quad 1, quad 1. Also, router 2 should advertise its LSA type 8, okay, for this interface, means I have connected to FE80:2, or also router 3. Because of that, router 1 now has 4 LSA type 8. Let me to show you the content of this LSA type 8. Show OSPFv3 IPv6. Then for viewing the LSA type 8, we should use the keyword of, for example, link, database, link. Link means LSA type 8, as you can see here. Then advertiser, router quad 1. Okay, here we have this information. Router 1 sent this information. I have connected to the link local address FE80:1. Okay, and also the prefix of this link is 2001 DB8 :2.2.64. You know that we have learned about the 2001 DB8 :2.2.64 before, and you know that we had topology of R1, R2, and R3, and we know that this link has the IP address of 2001 DB8 :2.2.64. Now the router 1 says on this link I am using the link local address of FE80:1, means on this interface. Also, on the 2001 DB8 :3.2.64, I am using the FE80:1. It is so easy. Okay, you know that finally each rotor should create this topology, because before the LSA type 8 we had the topology from the LSA with the LSA type 1, and also we have the addresses with the LSA type 9. Now we have the link local address of rotor 1 with the LSA type for example 8. Also in the rotor 2, let me to show you the information that we are receiving in rotor 1 from rotor 2. Show OSPFv3 IPv6 link, okay, IPv6 database link. Advertiser rotor is quad 2. Here we have this information that for the 2001 DB812/64 interface or subnet, I am using FE80:2. That's it, FE80:2, this interface. Okay, and also I received from the rotor 3, show OSPFv3 IPv6 database link advertiser rotor quad 3 can show us that here we have this information for the prefix 2001 DB813:64. I am using FE80:3 as the link local address. After this LSA type 8, okay, we can draw all of this topology, include the addresses, I means global addressing, and also the, for example, link local addressing of topology in the mind of each rotor. Also here we have one important notation about the LSA type 8. You know that, for example, about the LSA type 1 and also LSA type 2, okay, the scope of these two type of LSA is area. This is the area scope, okay, LSAs. Also, for example, we have some type of LSAs like the LSA type 5, okay, the scope of this LSA is AS scope. You know that we can advertise the LSA type 5 from one area to another area. But in the IPv6, in the OSPFv3 actually, we have another type of scope for LSA type 8. Okay, this LSA has the scope of the link local. I will talk about that, not area. Look at here, LSA type 1, area scope, LSA type 2, area scope, LSA type 3, area scope, LSA type 4, area scope, LSA type 5, AS scope, LSA type 6, area scope, but this is not supported, LSA type 7, area scope, LSA type 8, link local scope, and area LSA type 9, area scope. Let me talk about it. Look at here. You know that the link local address of the interface of R2 is not important for R3. Why? Because we cannot use link local address for sending traffic from other, for example, network, other segment, other subnet to this subnet. You know that link local address is using only for the, for example, local subnet communication, not inter-subnet communication. Because of that, let me to say that when the R2 creates its LSA type 8, okay, to the router 1 and send it to the router 1, router 1 can use it, and it is use it, okay, it is using the LSA type 8 of router 2, but it doesn't send this information to router 3. Actually, the LSA type 8 of router 2 only is available in the router 1 and also in the router 2, not in the router 3. Let me to show you. In the router 3, if you check the database, show OSPFv3 IPv6 database, here as you can see about the LSA type 8, we have only LSA type 8 of router 1 and router 3. This is new for us. Why? Because we expect to see exactly same LSTB on all routers of one area. This is true only with one exception, about the LSA type 8. Okay, you know that about the LSA type 1, type 2 and other LSAs, except the LSA type 8, we have the same LSTB on the routers on one area. But about the LSA type 8, the LSA type 8 scope is only local of the link, not local of the area. Because of that, we are sending LSA type 8 of router 2, the router 1 is receiving it and it is using it, but also it doesn't advertise it to the router 3. Also, we are receiving LSA type 8 of the, for example, router 5. Let me to show router 3. Let me to show you. This is the LSA type 8 of the, for example, router 3 receiving in the router 1. Router 1 is using this LSA type 8, but it doesn't advertise it to the other routers. Also, the router 1 should send its LSA type 8, okay, to both router 2 and router 3. And because of that, we expect to see 2 LSA type 8 on the, for example, router 2 and router 3, and 4 LSA type 8 in the router 1. In the router 1, we had 4 LSA type 8, but in the router 3, okay, we have 2 LSA type 8, it's okay. In the router 2, show OSPFv3 IPv6, for example, database can show us we have 2 LSA type 8, okay. Also, let me to say that here, about the view of each router, about the topology, we have this view. Router 1, let me to first show you the view of the router 1. It is informative. Router 1 as the quad 1, okay, connected to the router 2. Here we have quad 2. You know that each router identifies all of the topology with only the router ID of the other routers, not the, for example, host name or some other thing. The router 1 know that it has the one link between itself and also router 2. Okay, this is the topology view of the router 1, and also it has one link, another link to the router 3. Also, the router 1 know about the information of the subnets. For example, here we know that we have this range 2001 db812:64. Okay, after that also the router 1 knows about the cost or metric of this link. Okay, for example, it knows that here it has metric 64. Okay, 64, also here 64. After that, about this link, the router between the router 1 and router 3, the router 1 knows about the, for example, subnets, and after that the cost. This is here we have the cost of 64 again. Okay, until now we don't have any difference between the view of the, for example, different routers with each other. But about the link, also here we have one look back. Let me to add it here. About the link local address of interface, we have differences in the view. Here we have this interface with the metric of 0. Okay, and also we have another interface here, 2001:2, and then 2001:, for example, 3. And also let me to say that the router 1 knows about the link local address of all interfaces, because router 1 connected to all of the links here, FE80:1, okay, for this interface, okay, and then for here FE80:2. Again, for this interface, it knows about the FE80:1, and for this interface, it knows about the FE80:3. Okay, that's it. This is the view of the router 1 to all network. But let me to show you the view of the router 2. The view of router 2 and router 3 is like to each other. You can use the view of router 2 for drawing the view of router 3. Look at here. This is again quad 1. This is again quad 2. We should only copy them. And then quad 3. Okay. Also, we have one link between these two routers, between the router 1 and also the router, for example, the 2. And also here we have another link between the router 1 and router 3. Okay. After that, let me to show you that here we are using this range. Router 2 knows about this range and also this range. Okay. About the cost also we have complete information in the router 2. Okay, 64, then 64. After that here we are using again 64. About the cost, about the link local address, the router 2 knows about the link local address of this interface and its interface. Okay. Also about the for example, loopback interfaces, we have information same in the all routers, as you can see here. But as you can see now, we have differences in the view of router 2 and router 1. The router 2 doesn't know anything about the link local address of this link because it doesn't need it. You know that we don't need to know about the, for example, the link local address of the interface of router 1 connected to router 2 because we cannot use it. Also, if you want to know about the router trees, for example, view, the router trees view is like the router 2, only here we don't have the view about the link local address of this link, but we know about the link local address of our link to the other router, for example, router. But actually now you can understand the functionality of the link LSA. And because the link local address is not available in the IPv4, we don't need to create one new type of LSA like the LSA type 8 for example, OSPF version 2. Now let me to talk about the LSA type 2. You know that in the OSPF version 2, we are using the LSA type 2 in the broadcast network, include with this information, the mask of the network and also the, for example, attached routers. But you know that in OSPF version 3, we don't want to use the addressing information in the LSA type 1 and LSA type 2, because if you use addressing information in the network LSA, when address change, even the subnet address change, you should send LSA type 1 and type 2. Because of that, as you saw, we have removed the LSA type 1 addressing information and we are using the LSA type 9. Also about the network LSA, okay, in the OSPF version 3, we don't have any addressing information, include the, for example, subnet mask. Okay, let me to show you. It is so easy to understand the difference between the LSA type 2 of OSPF version 2 and OSPF version 3. First, let me to add this link again. You know that we have configured the addressing information under fast Ethernet 00 of the router 2 and router 3. Only we should enable it. Look at here in the router 2, conf t interface fast Ethernet 00, no shutdown. Okay, and also in the router 3, conf t interface fast Ethernet 00, no shutdown. Okay, after that we should enable the OSPF version 2 on the router 2 and also on the router 3, and after that OSPF version 3. First, OSPF version 2, router OSPF 1, network 10.2.3.2 quad 0, and then again area quad 0. After that, in the router 3, network on the router OSPF 1, router, for example, OSPF 1, network 10.2.3.3 quad 0, area quad 0. Now, after some second, we will have neighborship between the router 2 and router 3. You know that here, first, the router 2 and router 3 should negotiate with each other and they should select the DR and BDR. After that, we will have one LSA type 2 from the DR. We expect to see the router 3's interface as the DR because the router 3 has higher router ID and the priority of OSPF between these two interfaces are same. Okay, now let me to show you what is happening. Do show IP OSPF neighbor. Do show IP OSPF neighbor can show us that now we should wait again for selecting the DR and BDR between the router 2 and router 3. This is the wait timer, about 40 seconds. Okay, now we have neighborship. Do show IP OSPF neighbor. As you can see, the router 2 interface is BDR and the router 3's interface is DR. Okay, let me to show you the content of LSA type 2. Show IP OSPF a database. We have one LSA type 2, and here show IP OSPF database. For example, network, then 10.2.3.3. As you can see, the information that we have in the LSA type 2 is include the network mask and also attached routers. Now, let me to configure OSPF, for example, version 3 on the interface of router 2 and router 3. On the router 2, we should use interface fast Ethernet 00, OSPFv3 1, IPv6, area quad 0. And also in the router 3, let me to use this command, conf t interface fast Ethernet 00, OSPF version 3.1, IPv6 area quad 0. That's it. Okay, now we should wait again. After some second, we will see that we have neighborship between the router 2 and router 3, and then we can verify the information that we have in the network LSA of the OSPF version 3. Let me to show you. This is the, for example, router 1, router 3. Okay, we can use in the router 1, the show OSPFv3 IPv6 database. Then we should use the network statement, okay, and then advertise router. First, let me to show you the DR in the router 3, okay. Show OSPFv3 IPv6 neighbor. As you can see, now we have neighborship between the router 3 and router 2. Router 2 is the BDR in the address family IPv6. Okay, in the router 1, we can use show OSPFv3 IPv6 database. Advertiser router is quad 3. Okay, here we have this information, but we want to see the only a network LSA. We should use network advertise router quad 3. Okay, here we have this information. Attach router quad 2 and quad 3. We don't have any information about the, for example, mask or some other things. Actually, in the network LSA of OSPF version 2, we have a little more information. Attach the subnet mask, but here we have only the attached routers. We can say the network LSA of the router of the OSPF version 3 is similar to the network LSA of OSPF version 2, exclude the network mask. Now we can review all of the topics that we have learned before. Look at here. About the router LSA of the OSPF version 3, okay, we can say that we have only the topological information of the router LSA in the OSPF version 2. Actually, here we have lower information. After that, about the network LSA, again, we have only the attached routers. We don't have subnet mask. And again, this means that we have lower information than the network LSA of the OSPF version 2. About the Inter-Area-Prefix LSA, we don't have any change with the summary LSA, but only here, as you can see, the name is changed to the Inter-Area-Prefix. After that, about the Inter-Area Router LSA means the LSA type 4. Okay, we have the same information, but the name of this LSA is ASPR summary. After that, about the external LSA, again, the name is changed only. We don't have any, for example, change in the content. LSA type 6 is same. LSA type 7 is same. Only the name is changing a little. But link LSA is new in OSPFv3. This is working for the for example, link local address advertisement, and also we have Intra-Area-Prefix LSA. Here we have all of the information that we had before in the router LSA and network LSA of the OSPF version 2 about the addressing. As you know, in the OSPF version 3, with adding these two LSA type 8 and type 9, and first we are advertising the link local address, and also we are for example, using more efficient way for advertising of the information, as I explained before. Actually, we can say LSA type 1 in the OSPF version 2 equal to the LSA type 1 and 9 in the OSPF version 3. LSA type 2 of the OSPF version 2, we can add it here. Okay, LSA type 2 of the OSPF version 2 equal to the LSA type 2 and type 9 of the OSPF version 3, and OSPF version 3 LSA type 8 is a new LSA. Until now, we have learned about the, for example, link states of the OSPF version 3. Now let me to give you a little more information about the link state type code. For understanding the link state type field in the OSPF version 3, it's a good practice for verifying the or comparing the link state type in the OSPF version 2 with OSPF version 3. Let me to show you. For example, we can capture one of the links here between the router 1 and router 2. Okay, and after that we will see some differences between the link state type of the OSPF version 2 and OSPF version 3. This is OSPF. If you want, you can use a clear IP OSPF process for generating, for example, the new link state. Okay, or if you want, you can shut down one interface, serial 10 shutdown. Okay, in the router 1. After that, let me to enable it again, no shutdown. Now we should wait to receiving to link state update. Yes, it's okay. Let me to stop it. This is the link state update of the OSPF version 2, 10.122.224.0.0.5, and this is the link state update of the, for example, OSPF version 3. As you can see, in the OSPF version 3, we are using the link local address as the source IP, but the destination in both of them are multicast IPv4 or multicast IPv6 address for the, for example, OSPF. Let me to show you first 10.122. This is the link state update of the OSPF version 2. As you can see here, we have one header, include version 2, message type is ls update, packet length, source OSPF router is quad 2, area ID, checksum, authentication type, and authentication data. This header is same in all of the OSPF packets, okay? After the header, we have the update packet. This is the ls update packet. Here we have, for example, number of LSAs 1, and we have one LSA type 1, okay? This is OSPF version 2. Here we have some field, LSA, you know about the LSA, and also options, link state type, and some other things. I'm going to talk about the link state type. Look at here, in link about the link state type, as you can see, we have only for example 8 bits. As you can see 01, here you can see 0101 is a 2 hex character, means the link state type in the OSPF version 2 has only 1 byte or 8 bits. But let me to show you the link state type in the OSPFv3. You know that we are using ls type 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 in the OSPF version 2. With 2, for example, hex character, you can easily show these ls types with the 01, 02, 03, 04, 05, 06, 07, 08, 09, then 0, if you want, you can use A, okay, and then B. That's it. Let me to show you the ls type in the OSPFv3. Exactly the same packet. Here again we have the link state type. As you can see, the ls type has 16 bits. 16 bits means 2 byte. Actually, we have 2 byte for the link state type in the OSPFv3. This is the first difference that we should know. After that, I will talk about the detail of these 2 byte. Look at here, OSPF version 2, 8 bits for the link state type, okay? And also OSPFv3, in OSPFv3, we have 16 bits, okay, 16 bits or 2 byte for the link state type. Now we are talking about this, the detail of this 16 bits and how we can understand the detail of this 16 bits. Here you can see first the LSA types, type 1, type 2, type 3, 4, 5, and 8 and 9. The name of the type 1 is router LSA or device LSA. In most cases we say router LSA, but here you can see the other name, device LSA. Network LSA, Inter-Area-Prefix LSA, Inter-Area-Router LSA, AS External LSA, NSSA LSA, a Link LSA, and Inter-Area-Prefix LSA. Also, this is the ls type field. Here we have 16 bits. First, you should understand the functionality of these 3 bits. After that, we have 13 bits for the function code, and we can talk about this, for example, all of these bits. First, U-bit. U-bit is the abbreviation of the unrecognized bits, okay? Indicates how a router should handle an LSA if it is unrecognized. Look at here. As you can see, in the unrecognized bits, if you have the 0 value, treat this LSA as if it has link local scope. Store and flood this LSA as if type understood. What does it mean? It means that if the unrecognized bits is 0, okay, we shouldn't forward it. And if assume that R1 receiving one LSA, R1 doesn't understand it, and because the U bit is 0, it shouldn't forward it to the other routers. But if the bit is 1, okay, this means that if R1 doesn't understand this LSA, okay, it should forward this LSA to other routers, means it shouldn't drop it. That's it. And then S2 and S1. S means scope bits, indicate how the LSA should be flooded. Here you can see the rules. If we are using in 2 bits S1 and S2, 00 means this is link local. 01 means this is area local. 10 AS local, and 11 now is reserved. About the function code, okay, we are using the remaining bits of the link state field, indicate the function code of this LSA, and for example, function code of 1 maps to router LSA and other types, for example, 2 to the network LSA and some other things. I will show you. Let me to calculate this LS type for you for better understanding. For example, in the LSA type 1, okay, or the device LSA, we have 2001. What does it mean? First, you know that the scope of LSA type 1 is area. Because of that, in the S bit, we are using 0, S20, S11. Look at here, it is so easy. Here we have 0, 1. Also, in the U bit, assume that in the U bit we are using 0. This is the default. And then in the function code, in the 13 bits of the function code, we are using 12, 0, 1, 1, type 1, okay? 1, 2, 3, 4, 5, 6, then 7, 8, 9, 10, 11, 12, 1, 13, okay? And now you can gather all of these bits beside of each other. Let me to show you. 0, 0, 1, 0. We can write it here. It is easier. Let me to add a 0, 0, 1, okay, to this value. Now we have a 2 byte. This is the 2 byte. Here you can convert it to the hex. This is 2, this is 0, and then 0, then 1. 0x 2001. As you can see, this means that this is LSA type 1. After that, about the LSA type 2, everything is same, only the function code is 2. 2002, as you can see. About the LSA type 3, again, because this is local area LSA, we have 2003. Again, 2004 for the LSA type 4. But for LSA type 5, you know that the scope of this LSA is AS. Because of that, here we should use 1, 0 instead of the 0, 1. 1, 0 means here now we have this value. Look at here, 1, 0, and also LSA type 5. Here we have 0, 1, 0, 1. Okay, this is equal to 4005. So easy. Okay, 4005. About the NSSA area, again we have a scope of 0, 1, and then because of that, here we have 2007. 2000, for example, 7. And after that, this is 2007 because in the last hex state, in the last 4 byte, we have 0, 1, 1, 1. That's it, 7. After that, let me to talk about the link LSA. In link LSA, we are using, because this is link local, we should use here 0, 0. Okay, 0, S1 is 0. And then because of that, the result is 0. And here we have 8. So easy. And for LSA type 9, again, this is 2 and 2009. As you can see, you can easily understand the link state types. Also here in the, for example, our capture, we can find them. LS type 1, 0x2001. LS type 9, as you can see, 0x2009. And also, if you want, you can find the next LSA, include the LSA type 8. Okay, in the LSA type 8, we will have the, for example, 0008. That's it. This is the story of the link state type in the OSPFv3. As you can see, we have a longer LS type field, but this is detail of the OSPFv3. It's not important to, for example, remembering this LS type. This is only for our more information about the LSAs in the OSPFv3. Also in OSPFv3, or in OSPFv3 LSA, okay, we have some option bit field. Let me to show you. This option bit field describe the router's capabilities. Let me to show you. For example, in the our capture, we can find the option field. For example, about the LSA type 1, as you can see here, we have some options. Let me to show you. And some of them is, for example, DC, LN, MCE, and MT. Okay. Also, we have some other options. Let me to show you in other LSAs. LS update. This is for LSA type 1. Okay. DC, RE, and also V6. Let me to explain a little them. But if you want, you can see them in the database. Show OSPFv3 IPv6 database advertise router. For example, quad 1. Look at here. And if you want, you can see show OSPFv3 IPv6 database, then router, advertise router quad 1. Here you can see the options: V6 bit, E bit, R bit, DC bit. Let me to explain them. Maybe it is useful for more understanding of the OSPF version 3. First, we can talk about the V6. As you can see, V6 bit is set. What does it mean? This bit indicates that this router has the capability of the IPv6 routing, and actually we can say this router is participating in the IPv6 routing. V6 bit. Another option bit is the MC bit. MC bit it means a multicast OSPF or multicast extension for OSPF, MOSPF. You know that in MOSPF we are using LSA type 6 or group membership LSA. But let me to say that in Cisco now we don't have the option of using the multicast OSPF, and this is only for reference in the link state of the OSPF. And let me to say that in RFC 5340 in 2008, the OSPF deprecated, and because of that actually we can say in none of the brands you can find the functionality of the MC bit. MC means multicast OSPF. The next bit is the for example R bit. What is the meaning of R bit? As you can see, the R bit now has value of 1, means this is working now. In OSPFv3 we have one capability. This is useful. Let me to talk about it. Look at here. In sometimes one router can for example participate in the routing exchange. For example, router 1 advertising link state to router 2 to router 3. And in some cases, router 1 can participate in both routing, update sending, and also in forwarding of traffic. Okay, when the R bit is set to 1, this means that this router, okay, router 1 now can advertise the updates, the link state update to router 1 and to router 2 and router 3, and also it is participating in the forwarding of traffic. Okay, in some cases, for example, router 1 is busy, it can set the R set to 0. This means that I can send to you the information about the link states. Okay, but please don't use me as a transit router. Actually only send traffic to me when you want to reach to the network directly connected to me, or we have only one pass from me. Okay, assume that here router 3 has 2 paths to router 1. One path is the better path or the best path from router directly this link, and another path is from this link, the fast ethernet 00. But the path from the serial 10 is better path. If R1 set the R set as to 1, this means that you can send directly traffic to me, okay, for my network and also for other networks. For example, the network that we have connectivity to them from the router 2 to the router 2. Okay, you can send me, and after that I can forward the traffic to router 2. Actually, I am working as a transit router. But when you set the R set as 0, means please send the traffic to me only that I have the only path to that network because I'm busy. Please don't use me as a transit router. Okay, this is useful, and we have a feature like it in the ISIS routing protocol. After that, the next bit is the, for example, E bit. As you can see here, we have the E bit, and E bit is set also. This is so easy. Look at here. E bit means this router is working in one area, that in this area we can use external LSAs. Okay, what does it mean? You know that in a stub area we don't have link state type 5, okay, or external LSA. But here we are working in the area quad 0. Area quad 0 is normal area, and in the normal area we can use LSA type 5. Actually, when one router is configuring for one area with the area ID stub, the E bit should set to 0, and after that the other routers, okay, doesn't establish neighborship with that routers, exclude the routers that are configured with the area ID stub. Actually, with this E bit, the two router can understand that the other router is working in the area stub or not. And we can say the E bit indicate that the router is capable of processing external LSA. A router in the stub area set this bit to, for example, clear or 0, and neighboring routers do not form adjacency if they have mismatched E bit setting. Okay, until now we have learned about the V6 bit, E bit, R bit, MC bit, and also, for example, let me to talk about the DC bit. DC bit is not so, for example, useful for us today, but let me to explain it. DC bit or DC is the abbreviation of the demand circuit. Okay, for example, in some legacy circuits such as the ISDN BRI, we have used this feature DC bit. Okay, what is the meaning of DC bit? When one router set the DC bit, actually this means that this router indicating that it is capable of suppressing future hellos from being sent over the interface. This means that if you want, I can suppress the hello sending. Okay, I have this capability. This feature is useful in some low bandwidth links that are beyond the scope of this class, but let me to say that in most cases we don't use DC capability today. It's because in the LAN and also in the WAN today we have enough bandwidth. Because of that, the hello is not using more bandwidth, or for example high bandwidth. Because of that, we for example prefer to sending hellos. If you set DC bit, means this router, okay, has capability of suppressing the hello. Okay, also here we have another bit, the N bit. N bit is like the E bit, but you know that in E bit we are notifying that I have the capability of external LSA processing and forwarding. Means this router is not working in area stop. But N bit means the same feature about the NSSA external LSA type 7. Okay, this means that this router support type 7 LSA, means this router for example is working in the NSSA area. Actually neighboring routers do not form an adjacency if they have mismatched N bit setting. Because of that, we can easily understand function of some of them, but let me to say that all of this information are the low level knowledge about the OSPF, and maybe in practical world you use them in rarely cases, but it is a good practice for about informing them. Here in the database of router 2, show OSPF2. Let me to show you, show OSPF2. After that IPv6, then database. For example, we can use router, then quad 1. Here we can see advertise router quad 1. We can see these flags. Look at here. These options. V6 bit means this router has the capability of IPv6 routing. E bit means LSA type 5 capability. R bit, as I mentioned before, means now this router is actively participating in the forwarding of the traffic, and DC means that this router has the capability of the, for example, demand circuit and usage, and also for example we can suppress the hello if it is necessary. And now we know about the detail of the link state advertisement in the OSPF version 3. Let me to review some of the functions, some of the capabilities of the OSPF version 3. We have learned about them in this class, and now let me to review some of them. You know that in OSPF version 3, okay, we are supporting multiple address family. As you saw here, let me to configure this scenario for both IPv4 and IPv6 with the OSPF version 3. In the router 1, okay, you know that we have configured IPv4 routing with OSPF version 2. Okay, let me to remove the OSPF version 2, no router OSPF version 1. No router OSPF process 1 in the router 1, and also in the router 2, no router, okay, OSPF 1 again in the router 3. Let me to show you, no router OSPF 1. As you can see here, now we have only one routing protocol, OSPFv3. Let me to show you, show IPv6 protocols. As you can see, we have the OSPF version 3 here, but show IP protocol can show us that we don't have any routing protocol. Let me to configure the OSPFv3 for IPv4 routing. Router, for example, on the interface, we have configured router OSPFv3 before. Because of that, only we should go to the interface serial 10 with this command, OSPFv3 IPv4, okay, area quad 0. That's it. Also on the interface serial 11, we need the same command, and finally in the interface loopback 0, we need to use the same command. Let me to configure the router 2 also, interface serial 10, OSPFv3 IPv4 area again quad 0, okay, and then on the serial 11, as you can see, we have neighborship. On the serial here, we don't have serial 11. We should configure on the interface loopback 0 only. That's it. And finally, on the router 3 interface serial 10, OSPFv3 IPv4 area quad 0, and then interface loopback 0. That's it. Now we have configured this scenario with the OSPFv3. Actually, now as you can see here, we have support for both IPv4 address family and IPv6 address family. Let me to show you. R1 here, show a OSPFv3 IPv4 neighbor can show us that we have neighborship with router 2 and router 3 for the for example IPv4 address family, as you can see here, and also show OSPFv3 IPv6 neighbor. Exactly same information, but this is for IPv6. Also, if you want, you can verify show OSPFv3 IPv4 database, okay, and then IPv6 database. Okay, it is same. And after that, let me to show you, you can verify them. You can easily configure this scenario, and after that identify all of the LSAs that I have explained before. Also show IP, okay, root OSPF, or show IP root OSPF. Here you should use OSPFv3 because we are using OSPFv3 for completing the IPv4 routing table. We have quad 2 and quad 3, but in the show IPv6 route we have show IPv6 route from the OSPF. We have the similar information, okay, and then let me to show you show IP route OSPFv3 again, and show IPv6 route. Okay, here because we don't use the OSPFv2 for IPv6 routing, you can use only show IPv6 route OSPF. Look at here. Here we have a 2000 to a quad 2/32 with the metric of 64. You know that the reason is that in OSPF version 3 the cost of the loopback interface is 0. Because of that we have cost of 64, and to the quad 2 and also to the quad 3. And here we should assign IP address to the link between router 2 and router 3. Let me to check it here. On the fast Ethernet 00 we didn't enable the OSPF version 2. Interface fast Ethernet 00 OSPF version 3 for IPv4. OSPFv3 IPv4 area quad 0 first command, and then on the router 3 interface fast Ethernet 00 OSPF version 3.1 IPv4 area quad 0. That's it. Okay, after some second we will have neighborship between the router 2 and router 3, and in the routing table of the IPv4 learned from the OSPFv3, now we have 10230/24 with the metric of 65. Like the show IPv6 route, we have the similar information. As you can see here, now we are routing the IPv4 and IPv6, both of them with one routing protocol. Actually, we can say that the OSPFv3 support for multiple address families. Also, as you have learned previously, we are using neo LSA types, okay? And also, as I mentioned before, we don't need to address all of the, for example, connected link between the router 1 and router 3, router 1 and router 3. You can use only the link local address. Actually, you know that the IP prefix information is no longer present in the OSPF packet headers. Instead, it is carried as LSA payload information, making the protocol essentially address family independent, similar to the ISIs. Okay, and also we have learned about the functionality of the difference between the LSA type 1 and 2 of the OSPF version 2 and OSPF version 3. Also, you know that here about the packet format, we can say the OSPFv3 or like the OSPFv3, okay, v2 run directly over the IP protocol. OSPFv3 runs directly over the IPv6, and you know that here the number of fields is reduced because here in the OSPFv3 we don't have the authentication field and some other fields. Let me to show you. Look at here. This is the OSPFv3. Okay, we can verify it. This is the capture of a previous version of OSPF version 2 and version 3. Look at here in OSPF version 2, as you can see, in the OSPF header we have, for example, this amount of information, but in the OSPF version 3 we have lower number. Look at here, version 2 version 3. This is same. Then message type, here also we have message type. In the version 2 packet length, in the version 3 packet length. And also about the source OSPF router, we have this information on both router. About the area ID, we have same information. But as you can see here, we don't have authentication data, authentication type, checksum. We have this information in the OSPF version 2, but in the OSPF version 3, we don't have these options. And we can say the number of fields in the OSPF version 3 is lower than the OSPF version 2. After that, as you can see, we are sending OSPF version 3 packet directly over the OSPF version 2. And here you can see the next header include the 89. This is like the protocol field in the OSPF version 2. In the OSPF version 2, we are using protocol field, and the number of protocol again is 89. Also about the authentication, we have learned that neighbor authentication has been removed from the OSPF protocol and is now performed through IPsec extension header in the IPv6, for example, packet. Another benefit that we have on the OSPFv3, okay, is that we have one option, we call it multiple instances. Look at here, we can run multiple instances of OSPF in one segment. Let me to show you here. In the OSPFv3 packet, we have this information, okay, OSPF header, instance ID, okay. We don't have the instance ID option in the OSPF version 2. I will show you this option in the next video. This is one of the benefits of the OSPF version 3. Actually, we can say that in OSPF version 3, about the LSAs and some other detail, okay, we have some benefits in compare with the OSPF version 2. But finally, in compare between these two protocols, we can say that OSPF version 3, okay, is mainly working on base of OSPF version 2. But here we have some new features for more efficiency. Let me to show you the functionality of the instance ID in the next video, but let me to say that this is beyond the scope of this course. It is only for your information. And also after that, in the next video after the instance ID, we will learn about the OSPF version 3 authentication feature. It is so easy. You will learn easily the authentication of the OSPF version 3, and you can understand what is the benefits and also what is the difference between the OSPF version 3 authentication and also OSPF version 2 authentication.